We continue our discussion on probability. We take up continuous probability. As we mentioned in the previous session, probability is of two types, continuous and discrete. Now, looking at continuous probability, one of the prominent ones is normal distribution. Within normal distribution, there are two aspects we look into. One is probability density function, another is cumulative distribution function. What is density? It's in simple terms, density means frequency. A classic case is supposing there's a group of students whose age varies from 20 to 25. Now, there can be a question pertinent to the age 21. Who is age 21? What is the count? So people say 30% belong to that particular age, and there's a frequency attached to it. 15, let's say. That particular number is an example for density. So, in formal terms, density means for a variable x, what's the probability of particular value of x to occur? That is formally the density. And as per normal distribution, density comes from a specification. You can calculate density by using a specification. It's given on the slide. Probability of any value of x to occur equals 1 upon sigma root of 2 multiplied by pi, the whole thing multiplied by e raised to half multiplied by x minus mu upon sigma all squared. Now let's see what each symbol signifies. X is a random variable. Sigma is its standard deviation of x. Mu is the mean average of x. Pi is a mathematical constant. E is also a constant. That's what it means. That's what each symbol means. So we can have some examples. Supposing there's a firm. In the firm, mean age of employees, that's the mu, is 30. Mean, that's average. And standard deviation, sigma, is 3. What's the probability of x being 35? So if you substitute given information given in the box, we get a specification using which we can calculate. So probability of x being 35 is 1 upon 3 into root of 2 pi e raised to half 35 minus 30 upon 3 whole squared. Now we come to continuous probability. Continuous probability is summing across individual probabilities. So densities are being summed over a range that gives continuous probability. So there's a summation sign given. So let's look at the formula. It's 1 upon sigma root of 2 pi. That's factored out. Then the summing, there's a continuous summing, which is called integral, which takes a range from minus infinity to positive infinity. E raised to half x minus mu upon sigma squared, all squared, and multiplied by change in x dx. So if you see the symbols, a few new symbols we have brought in. One is integral, another is infinity. Let's have some workout. We can find out some answers to certain questions. We can find out answers